Uh, I wanted to explain you a little bit how does it work, the system in a real case. For example, we have an emergency beacon in, it seems to be Macedonia or Bulgaria. So the geolot automatically detects the beacon. That's nearly instantaneously. Luckily, there's a first LEO satellite pass which sees the beacon, and after it has passed the beacon view, it provides two localizations due to the Doppler effect. It cannot distinguish either it was on the right or on the left. So we have two positions. Therefore, we need another piece of information, so that's why we need another second pass in order to get two more positions. And then we see that A and A prima, they're quite close, so that means that we have a match. So we dismiss those B positions, and that's the actual position of the beacon that's been transmitted to the mission control centers. In terms of mission control centers, right now we have like nearly 43 or spread around the world. They are charged to collect and store the data from their MEOLATs, their local user terminals, and they also exchange the data by themselves, because one beacon can be located in Nigeria, but it can be seen only by a ground station in France. So the data is automatically relayed to the local authorities on where the actual SAR search and rescue mission should be take place. Regarding the data distribution, you see, for example, in this case in Bulgaria, you have a local SAR coordination placed at Varna. I guess that's in the Black Sea, and that's what we call a SPOC, which is a search and rescue point of contact. They will coordinate any search and rescue mission regarding the Bulgaria area. But Bulgaria doesn't have a mission control center, so it is reattached to the Russian mission control center. So any distress happening in Bulgaria would come forwarded via the Russians. Now that we have seen the actual system, which is working right now, and now I would like to transition to the newer system, what we call the MEOSAR. So I recap something here, the timeline, and what we call from LEO to MEO. So from the early beginnings, when the system was founded, to the first mission, as we saw, the system was declared operational in 1985, so quite quickly. In 1988, COSPAS-ARSAT was recognized by the United Nations. In 2000, we started what we call the D&E phase, so demonstration and evaluation, in agreement, that was an agreement with the European Commission, US and Russia, to transition the current system to a newer one with a few features that you will talk about later. About some more milestones here. The first two Galileo with carrying search and rescue payload were launched in 2011. We have here like a great milestone in next year, where we were supposed to declare the system operational, or what we call the initial service declaration. So what's different between the MEOSAR and LEOSAR, you may be wondering, right? Well, in terms of coverage, it's a knockout. So MEOSAR it is being conceived to be used by the three constellations, major constellations of global positioning, so GPS, Galileo, and GLONASS. So when those three constellations will be fully deployed, we will have approximately 72 satellites covering the whole world. So in terms of number of spacecraft available, that would provide like global instantaneous coverage. What about accuracy? Well, that's also better. The new system has evolved a little bit, the way of we calculate the position of the beacon in distress. It is really similar as this GPS that we have in our phones or in our cars, so but vice versa, in reverse. And on top of that, we have improved satellite communication links with the ground and with the beacon. So accuracy would be even better. In terms of availability, the system is nearly close to 100%. So the MEOSAR or MEOLAT ground stations, they have 4 antennas. They have redundancy in terms of physical hardware, and obviously the fact that they can work together. We'll see that in the few slides, but we have some extra features, as we call the network. So ground stations can work together, and so they can share their measurements. So even though maybe one station has 2 antennas out of service, it can continue to provide data, so system in general continues to be available. In time of response, or timeless response, that's also a knockout. It has instantaneous coverage, as I said, and not even coverage, but localization. The actual requirements says that within 10 minutes of the first burst emitted, the MEOLATs, a localization should be provided. So that's roughly 1 hour, or in average, 1 hour in advantage. And as I was telling before, advancing, there are some enhancements on the new system, as the exchanging of the measurements provided by the satellites, providing a whole network. And in addition to that, the Galileo Search and Rescue has introduced a new element to the system, which is an acknowledgement to the user. So actually, there's a way to be acknowledged on your beacon that is also capable of that, to be sure that your distress has been received and that aid is on their way. So that's a new feature that has been introduced only for Galileos, and that will be hopefully spread on the other constellations. What about the localization process on the MEOSAR? I just advanced a little bit before, but we need there's a beacon emitting, and in order to be localized, this burst should be seen by at least 3 different satellites. Those 3 different satellites will provide you with 2 measurements, each one of them. So the frequency of arrival and the time of arrival. Having those data from these 3 satellites on the ground, would be able to compute localization in terms of latitude, longitude, altitude, and frequency and time of when the beacon has been activated. So the network feature, imagine that there's a USA MEOLUT placed in I don't know, Hawaii, for example, and there's a European ground station in let's say Sofia, and a beacon that's in between. So the MEOLUT in Hawaii they see the signals emitting by this beacon with their 3 antennas, so they can provide a localization. So USA would be okay, but Europe, for whatever reason, the inclination of the orbits or the terrain or something, they only see these birds by 2 satellites. That would be not enough to provide a localization. So Miolot would keep waiting until new data comes in order to process this calculation. And thanks to the networking, those measurements can be sent to Europe, and then the Miolot also can compute a localization using the other data. So that speeds up the process and at the end provides data more accurate, because the more points, the more raw data you have, the more accurate you can be. Look on the actual Galileos. As I was talking, we have mainly 2 services, what we call the forward link, which is Europe's contribution to COSPAS ARSAT. It is mainly relaying to the ground the signal emergency picked up at any time. That's L-band in 1.5 megahertz. And the new enhancement or new feature, as we were talking as well, is the return link service. So we'll see how it works further on. And this message is disseminated on the ground via the navigation message. So in terms of ground segment, Europe has developed or has installed three ground stations with 4 antennas each. They are placed in Maspalomas in Spain, one in Larnaca in Cyprus, and another one in Spitsbergen, trying to cover the whole Europe, or what we call the European coverage area. We have also a coordination facility in Toulouse where we can oversee the system. We have monitorings of the 3 stations, and we also have what we call a tracking plan generation facility, which actually computes the satellites in visibility for all those 3 stations and tries to optimize for the better performance and the better coverage. And as well, we have a dedicated network relaying all those elements to work as one single ground station with 12 antennas. And in terms of the return link service, you may guess that the first part we have already seen it. We activate the signal with a return link message enabled beacon. So obviously the beacon should be prepared for that. So within the same distress message, they embed, they change a bit, and they request this feedback, this acknowledgement. So this is processed the Miolot at ground segment and goes to the mission control center, which can decode the message, and they see, oh, that's a beacon requesting acknowledgement. So obviously this search and rescue mission goes at the same time. We're not going to wait until the feedback is processed. So the search and rescue mission goes in parallel, but at the same time, a message is sent to what we call RLSP, or return link service provider, mainly a bunch of servers that computes the positions and the best satellites and view. And they send the message to the Galileo Mission Control Center, and they uplink the request for acknowledgement via C-band, and that's received and stored and processed by the Galileo satellites, which at the same time, meanwhile they are broadcasting their navigation signal. They encode the feedback for the beacon. And the beacon itself, well, that's the signal, the space signal. And the beacon itself, it is activated, obviously, and they decode the message. And the beacon ID matches the beacon ID of the one it's been emitting and requesting the feedback. And then something it's up to the providers to decide, but maybe you can have a LCD display saying message received, or maybe you have just a LED which can turn blue, red, whatever. So you get the idea. And after that, we'll just a quick testimonial what happened in March this year to prove that Meosar is also functioning and that would improve the actual system. So a hunter was in distress in a mountain area in New Zealand. At that time, he activated the beacon, and the LEO satellite just was right out of the view. So bad luck. It was kind of a rock terrain. There were plenty of trees, so GEO couldn't have enough visibility, so nothing was seen. However, he was lucky that two GPS were flying by. So they picked up that signal because they have like plenty of different planes, those with more inclinated orbits. They were able to pick up that signal and forward it to the rescue center, and the guy was found alive. And to conclude, I will just a video of what's going to be the future steps. That's development ongoing by Thales Alenia. The actual improvement is here. As you can see, a classic ground station can be between 4 to 6 antennas, because they should be tracking different satellites. And the fact that they managed to put it in a single 2 by 2 meter infrastructure, that's really something. It's just a peek on what can be seen in the future. Here is the beacon ID. Well, it's too fast. And I think that concludes the presentation. If you have some questions, I'll try to answer them. Otherwise, it's been a pleasure. I hope you get with the idea that something is going on in this area of the search and rescue. I'm quite happy to be working on this field, which provides like tangible help to mankind, let's say.